Hi all, I am Roland and I am the extreme digital nomad. I write code, always and everywhere. Welcome to this episode of the Augmented Software Engineering Podcast. Please read the blog post that is in the description to understand what this is all about. In the last episode, we looked at Warp, my terminal program of choice. For me, Warp is one of the best terminals with built-in AI support that are available right now. Today, we want to take a look at another tool that is close to my heart. I am obviously talking about Emacs. Question is, can you use Emacs to do augmented software engineering? The answer is obviously yes. Let's get a feel for how this looks like, shall we? We are back with our trusted 99 Scala problems. Today, we will solve problem number 56. As always, we are looking for help in at least two ways. First, we want to have a chat window to ask questions. Second, we want help when it comes to editing code. Namely, we look for inline code completion capabilities. In my case, I am using two distinct packages to help me with that. I am using tel and copilot.l. We will take a look at these shortly. By the way, if you are interested in how all of this configured, please feel free to take a look at my Emacs configuration repo. Besides showing how to configure Emacs to have good AI support, it has lots of other interesting configuration and tooling hints, tips, and tricks. The link to the repo is in the description. Today, we want to solve problem 56. Problem 55 was about creating balanced binary trees. With that, we can create all balanced trees for a given number of nodes. But only some of these balanced trees will also be symmetric. Let's implement a method is symmetric on a tree to check if it is not only balanced, but also symmetric. Note, as you can see, and to help with the context management, I copied and pasted all of the problem descriptions into a text file. We will put that to good use in due course. Now, this is our first tel buffer. It will be the buffer we use to find a solution for problem 56. To set up more context for the AI to help me, I first ask the AI to explain problem 56 to me. The result is not bad. Not bad at all. Why is that? The results are good because you can obviously configure tel, either globally or per session. In our case, we have already configured some context, a system prompt, and have picked a model. Let's take a quick look how to do that using the tel menu command. In the tel menu, we can set and configure a lot of things, but the most important ones are the system prompt and the context and the model to use. My system prompt reads something like this: "You're a pair programming buddy for a software engineer." We are solving the 99 Scala problems. We are using Scala 3 and SBT. Please respond with idiomatic Scala 3 code. End of prompt. As you can see, we can also add buffers and files to the context. In general, I add my flycheck buffer and my test output buffer to the context so that the AI can help me with fixing errors that I have difficulties to fix myself. In our case, I am also add a file, and you guessed it, this is the description of all problems we looked at earlier. And this explains why the AI was able to explain problem 56 to us. Last but not least, let's take a quick look at the available models. As you can see, tel allows you to install and configure lots of different models. Some of them are hosted. Some of them are local, means they run on your laptop. In general, I use one of the hosted models, but when I am on a plane or in a place with no internet connection, then using a local model is a good option to have. For now, we will stick with GPT-4o Mini. Now let's take a quick look at the code that was suggested as a solution for problem 56. That looks good, but we want to take the already existing implementation for problem 55 into consideration. Let's cut and paste this code and polish it. Here's the code to solve problem 56. First, I am importing all of the data structures from problem 55. I am then using an extension method to implement the asymmetric method on the tree data type. That compiles. Let's write some tests. Note, to help me with the coding, I also have GitHub Copilot configured and enabled in this buffer. With that, I will get all the usual Copilot autocomplete goodness that we are accustomed to from using Versus Code and others IDEs. Now let's talk about tests. The first two tests are the ones that were suggested in the original chat. But then we can add two more tests. One where we test all trees that can be built from 4 nodes. And it is not hard to see that no tree that you build from 4 nodes can be symmetric. Furthermore, we test that 5 trees from 7 nodes are symmetric. But how do we know that? Easy. We just ask the AI. Here we can clearly see that you can calculate the number of balanced, symmetric trees and how to do it. Note, this goes against my normal workflow. In general, I do not use the AI to generate the test cases, but here I am making an exception. This was exciting. The gut feeling might tell us that you cannot use Emacs for augmented software engineering. That is not necessarily true. There are lots of simple, everyday tasks where simple editors like Emacs and Vim still have a place and a role to play. And there's good enough AI support available. Means you do not need to use Versus code for everything. But I have to admit that for all-in and full-on software development, fully integrated IDEs like Windsurf and Cursor are clearly 2 to 3 steps ahead of what Emacs can do right now. It comes down to picking the right tool for the task at hand. See you next time, and to not forget to like and subscribe.